So thermodynamics has two types of processes. One is the reversible process and the second is the irreversible process. So in reversible process, for example, let us take a ice cube and keep it outside the fridge, that is, it will melt, but the water can always be again converted back to ice. So that is a reversible process. So melting of ice is a reversible process. But in irreversible process, for example, if we bake a cake, the cake cannot be unbaked. I mean, it cannot be brought back to its original ingredients before making the cake. So once you bake a cake, you cannot reverse the process. So that is irreversible process. So in reversible process, the change can happen backwards, that is, it can be reversed back to its original process, original state. It can be reversed to its original state. Whereas irreversible processes cannot be brought back to its original state, that is, it is more natural. In reversible process, after a change occurs, the reverse must get it exactly to where it was, that is its original state. So in irreversible process, I can say that the entropy increases. So entropy is a new word and I'm going to explain that, which is entropy increases. In short, what does entropy mean is the disorder. So what exactly is entropy? So it means disorder because let's consider a liquid of, let's say, some metal, and the same metal, let's consider a solid. Now the entropy, that is disorder, is there is less disorder in the solid of the atoms and molecules and more disorder in the liquid. This means that the entropy is more in the liquid than the solid. So in a liquid, the motion and configuration of molecules is random. That is, the entropy increases. So as the entropy increases, it is more thermodynamically favorable. So thermodynamics is the change in heat energy. So you can relate it as favorable. So you can relate it as the entropy is the amount of disorder. So the more disorder there is, the more change there is, and dynamics is related to change. So you can remember it like that. So the more entropy, the more thermodynamically favorable. So let's consider a cup of tea. So we have this hot cup of tea. So the temperature is higher and therefore the entropy is also high. So the molecules and atoms present are moving at a very high speed as the temperature is high. Therefore the disorder is also more and therefore the entropy increases. So if you leave the cup of tea for some while, it will become cold. That is, there will be transfer of heat. So heat transfers from high temperature to a low temperature. That is, when the tea will get cold, the entropy will also decrease. For heat to transfer, what is required is difference in temperature. So from 0 to minus 14 degrees Celsius, also there can be a heat transfer. So let's summarize a few points about entropy. So first is measure of disorder. So let's just consider the three states of any metal. We have solid, liquid and gaseous. So the entropy is highest in a gaseous state. So the entropy is higher in a gaseous state than liquid, and the entropy in liquid is higher than that in solid. So as we've seen that the entropy is more in a hot object or element and less in a cold object. So, point number two, entropy is also the measure of how spread out the energy is. So, as we burn fossil fuels like coal, gas, the energy spreads out. So, that is how we use fossil fuels like coal. So, the third point, if you consider the arrow of time, that is, time always moves in the forward direction. Therefore, as time passes, entropy always increases in the universe.